Welcome back and thank you for joining me. Now, this is an exciting notes video because this is actually the last note video for chapter 2. So congratulations, you have made it through this very long chapter. So we're going to wrap up with our 2.8 notes and then prepare for our upcoming test after that. Now, I'm going to review really quickly with that example number 4, what we were doing in the first section of these notes. So the first section of the notes is graphing lines. Now, the goal here is I want to get y by itself. Remember, we always, for lines, want the y equals mx plus b form. So that means what I'm looking to do is get this y by itself. And how do I do that? Well, I'm going to divide both sides by 10. So I'm going to get 1 half x is greater than or equal to y. Now, I don't like the way this is written. When graphing inequalities, we need the y on the left-hand side, okay? So I'm actually going to flip my x and y where they are. Now, when you flip it, you also have to flip the direction of the inequality, all right? It needs to follow the y. So notice up here, the pointy side is facing the y, so down here the pointy side should still be facing the y. I just want it written like this because it's easier to see where we're going to end up shading and compare it to the line. However, first we need to graph this. So y is less than or equal to 1 half x. So remember, when there's no y-intercept, here you can basically consider that as adding 0. So that means my starting point is going to be the origin, okay? When there's no constant, remember you begin at the origin. And now I have my slope of 1 half. So rise over run. Rise of 1, run of 2. Rise of 1, run of 2. Rise of 1, run of 2. And to get my most accurate line, I could keep going in the opposite direction as well. And now I take a look at my inequality. Less than or equal to. That or equal to piece, remember, that means that I get my solid line. Or equal to means my line is actually part of my solution set. And then I look that my y is less than that line. Well, where is less than that line? I take any point on the line. Less than is going to be represented beneath it. So everywhere beneath this is going to be shaded, is going to be part of that solution set. So that's kind of wrapping up the idea that we started with in the first notes video. Now, inequalities actually do move beyond that. They actually end up with absolute value inequalities as well. So the first thing I want to recall with you in example 5 is I want to recall how do we even graph absolute values, all right? So remember, we are going to start by finding the vertex. Now the vertex comes from the x minus 2 and the plus 3. The x minus 2 is giving us the x value of the vertex. And remember, that negative 2 means you are shifting to the right. So you're going to end up with a positive 2. And then the plus 3 is giving you the y value of the vertex. Remember, x is you're kind of flipping it. You're doing the opposite of what you'd expect. That y shift, that plus 3, you end up doing what you'd expect. Again, a little bit backwards from what we're used to thinking. Now, I'm going to plot that point. So 2, 3 puts me right there. That is my vertex. So remember, after finding the vertex, I give my attention to that negative 4 there. That is my vertical shift, all right? So what that means is that is actually giving me the slope I should be using for this inequality. I have a slope of negative 4. Now, before I do that, I'm going to put in my line of symmetry that every absolute value has Now, slope of negative 4. So I start at that point, and I go down 4 over 1. Now, I also get that mirror image point on the other side of it. We cannot forget to get those mirror points. That's how we're going to get the V shape. Now, I go back, down 4 over 1 gives me that point, and I get its mirror image over there. So, I'm getting the V shape that I'm looking for. I've got what I'm looking for. Now, the next thing is to see solid or dashed. My y is strictly less than. So, strictly less than means I'm actually getting dashed lines instead of solid lines. My absolute value is not part of my equation this time. And now, y is less than my absolute value. So, less than my absolute value. So, I'm going to start at the vertex. Where is less than the vertex? Well, less than is down there. So, in this case, I'm getting that inner region getting shaded. Okay? So that's where we're going to end up shading this time. You're either shading kind of the inside of the absolute value or outside. So again, what I would do is I would start at the vertex, and that's a point that I would use. Am I going greater than or less than it? So let's do another example. Now this one is getting slightly more complicated because this time we have an absolute value. However, our our solution is not really, or our equation is not solved for y. So I need to consider, what am I going to end up doing here? Well, the first thing I'm going to do, I'm going to move that 2 over. So I'm going to subtract 2 from both sides. So I'll have negative y less than or equal to negative absolute value 2x plus 1. Now if I'm minusing 2 from that 6, that's just going to leave me with a plus 4. All right, so I've moved the 2 over, but now I still have a slight issue. Not negative y. I don't want negative y, I want actual y. So what I'm going to end up doing to take care of that is I'm going to divide everything by negative 1, because that's going to flip my sign of everything. I'm going to end up with that. Now, don't forget, when you multiply or divide by a negative number, you are going to get that. All right, now, we have a little dilemma here because we've never seen something like that. The only thing that we've ever seen is an x plus a number or x minus a number. We've never seen anything more complicated inside there. So the next thing that I have to do to take care of graphing this is I'm actually going to end up pulling that 2 out. Because now this looks like something that I know how to graph. Okay? So that's the other thing is if the x inside the absolute value isn't by itself, just pull it out because now this is in a form that we are going to be familiar with graphing. Again, we need these 2 pieces to give us our vertex. So remember, the vertex is, for the x's, the opposite of what you're seeing. That x plus 1/2 is actually shifting it to the left 1/2. And then we have that negative 4 for the vertical shift, the y shift. So negative 1/2, negative 4 puts me right there. So that's the first point that I'm going to plot. And now I look at that 2 that I have out front, my vertical stretch. So for every 1 I go over, I go up 2. All right, so I'm going to plot some more points. Up 2 over 1. Now, don't forget, we do have that line of symmetry through the vertex. So don't forget to plot your opposite points, your mirror image points here. So up 2 over 1 again, and then I get the mirror point. Up 2 over 1 again, and I get the mirrored point. Up 2 over 1 again, and I get my mirrored point. Up 2 over 1, get my mirrored point. All right, so I've got my V shape that I'm looking for. Next, I'm going to focus on the direction of the inequality. Greater than or equal to. Or equal to means we're actually getting solid lines. Our lines are part of our solution set. And now greater than or equal to. Well, greater than or equal to, starting at my vertex, greater than would be above it. So in this case, it is my inner region that is going to get shaded. Everything in that region above the vertex. And that's how you're going to take care of these absolute value inequalities. Just graph the inequality and then use the exact same method to determine where to shade. Now, another skill we're going to need is being able to write our own equation given an inequality. So, the first thing I'm going to focus on is getting my equation of the line. That's going to be the first step, all right? Find the equation of the line. So, first step in that, my y-intercept is up there. So, and that is at 1, 2, 3, 4, 5, 6, 7. So I know my constant is going to be plus 7. And now I want to determine my slope. All right, well, it looks like my next point is actually on a line, or on a grid point, is right there. So to me, it looks like I'm going down 3 and over 1. So down 3 over 1 would be a slope of negative 3. So I have negative 3x plus 7. Now, the next thing I need to do is determine my inequality sign. So my inequality sign. Well, first of all, I have a dashed line. So remember, dashed line means that or that. Okay? So that's what the dashed nature of this line is telling me. Now I'm also realizing that it is shaded above my line. Notice if I go to any point, it is always above it that is shaded. So above means greater than. So I want my y to be greater than that line. So again, it's the same stuff that you've been doing, just now thinking in the reverse. Thinking, can we find the equations of these inequalities? So, last problem that we're going to focus on is this one. So I'm going to start with my y, and then I'm going to leave the inequality sign for later. I'm going to get back to that. I want to figure out my equation first. So the first thing I need to do is figure out my vertex. So when finding these, determine vertex. That's going to be our first step. So my vertex is shifted to the left 2. So left would mean adding. And then down 3. Right, and the next thing that I want to consider is the slope of those lines, because that's going to give me my vertical stretch. So determine slope or vertical stretch. So it looks like my next point is actually on a line, is right there. So what's it doing? Well, it's going up 3 and over 2. So it looks like that is going to give me my vertical stretch, my slope of the lines, up 3 over 2. And now my third and final step, again, is the inequality sign. I have to determine that. So this time, notice solid line. Solid line means we're going to be using one of those. Now, also notice, if I go at my vertex, where's everything shading? Well, everything is shading above that point. So above is going to be greater than. So I'm going to need my greater than version of this. So y is greater than or equal to that inequality, that absolute value. So that is going to wrap this up. So please make sure that you have all of these notes taken. I realize this is a lot in one video, so we're going to do quite a bit to practice this skill. So don't worry, you're going to get a lot of exposure to this. But please make sure that you have all this written down, and then we will continue practicing this in class.